Now we're going to look at one other kind of statement before we get into some more examples here. So something we've had a lot of so far are definitions. So definitions can actually all be written as if-then statements and their converse. So when it comes to definitions, what we say is that both conditional and converse are true for definitions. So they work in our if P then Q form and backwards, if Q then P. So remember, our conditional is if P then Q, and our converse is if Q then P. That's because definitions are true no matter what order you write them in. They're a definition, right? They're a fact. So for example, perpendicular lines. We defined that, I think the last section, like 1.4 or something like that. So if we write that as a conditional statement, it says if two lines intersect to form a right angle, then they are perpendicular lines, right? Our hypothesis here would be two lines intersect to form a right angle, and our conclusion would be they are perpendicular lines. That is a true statement. If you have two lines, they intersect to form right angles, then those are perpendicular lines. But if you take that statement and you flip it around, it is still true. So if we say, if two lines are perpendicular, then they intersect to form right angles. And that would also work, right? If they're perpendicular, then they're going to intersect to form right angles. Also a true statement, just written the opposite way. Statements that can be written both as conditionals and converses are called biconditional statements. So when both a conditional statement and its converse are true, you can write them as a single biconditional statement. So what that looks like is you'll have the phrase if and only if in the middle. So two lines are perpendicular if and only if they intersect to form right angles. That implies it works from the front to the back and from the back to the front. Okay, so it's a biconditional because it works in both directions. So how it's written is P, so our hypothesis, if and only if Q. So this is if and only if is like our phrase we put in the middle. And our symbol is, instead of just a one-way arrow, you'd have P and then an arrow in both directions because the phrase works in both directions, and then Q. On our definition sheet that you're going to have, this is actually how all our definitions are going to be written, is in if and only if form so that they work both ways. So just going to take a look at a few different examples here, deciding if things are true or false, right, based on some of the definitions we've learned. So determine whether the statement about the diagram is true and explain. So this is saying line AC is perpendicular to line BD. Well, if you look up above, we know perpendicular lines are going to intersect to form right angles. And if you take a look at your picture here, we have line AC intersecting with line BD, and I see a right angle box here. So that means these lines are intersecting to form right angles, therefore they are perpendicular. So we would say true because perpendicular lines, remember our upside down T means perpendicular, intersect to form right angles. If that right angle box was not in our picture, then we would not be able to say that for sure. It might look like a right angle, but unless it has the proper labeling, we can't be positive. Next one says angle AEB, so AEB. Oh, and what I'd like you to do is where they're intersecting here, that's going to be point E. So angle AEB and angle CEB are a linear pair. Well, our definition of a linear pair, and this is in your vocab sheet, a definition of a linear pair is that you have a pair of adjacent angles that their non-common sides form opposite rays. And right here from E to A and from E to C, we have opposite rays. Therefore, this is a linear pair. So we're going to say true because, and I'm going to abbreviate B/C as because they are adjacent angles. And I'm abbreviating angles. I do that sometimes. You'll see me write like the congruent symbol instead of congruent. You're allowed to do that as well if you want. If you don't want to, write out the word. So because they are adjacent angles that form opposite rays, right? If these were not opposite rays, then it wouldn't work. And then ray AE and ray EB are opposite rays. Well, this one is going to be false because opposite rays must form a straight line. These do not form a straight line, therefore they are not opposite. So false because they don't form a straight line. Okay. And then a few things about biconditionals, and then we will move on to the next part. So rewrite the statements as biconditionals. Remember, our biconditionals are written with our phrase if and only if. So P, if and only if Q. So what we're going to have to do here is identify our hypothesis and then identify our conclusion. And put the phrase if and only if in the middle. So this says obtuse angles are angles with measures greater than 90 degrees and less than 180 degrees. So we have two bits of important information here. We have obtuse angles, right? So that kind of tells us what we're dealing with. So this is saying you have some obtuse angles, and those obtuse angles are going to have measures greater than 90 and less than 180. So what you're going to do is take those two parts and then put the phrase if and only if between. Make sure your sentence is logical. There's a few different ways to write it, but don't write nonsense. Make sure it is a logical sentence. So we're going to say angles are obtuse if and only if their measure is greater than 90 and less than 180. Okay. So we have our if and only if in the middle, and that would work. Angles are obtuse, right? Think of it both ways. If they're obtuse, then their measure is greater than 90 and less than 180. Or if you have angles that are greater than 90 but less than 180, they're obtuse. So it works both ways. And then if two angles are complementary, then their sum is 90 degrees. This is actually the definition of complementary angles. So it's written as an if-then, but it can also be written the other way. So it could also be written as if two angles have a sum of 90 degrees, then they're complementary. Therefore, we can write it as a biconditional. Just to make sure we understand here, we got our hypothesis, two angles are complementary, and then our conclusion is that their sum is 90 degrees. So, two angles are complementary if and only if their sum is 90 degrees. So that's it for this part of the video, and then we're going to move on to our reasoning with inductive and deductive.